All right. Lesson 34-2, and if we're looking at this, we are on page 500. We've made it to 500, guys. We are looking at solving problems by finding the volume of a prism and the volume of a cylinder. Now, these are actually 8th grade standards as well, so these are things that you may see on your iLearn this year. Volume of a prism and volume of a cylinder. Okay, so we're talking right now about a thermos. Okay, so Extreme Materials gives their tour guides a thermos before every excursion. Depending on the excursion, the thermos is either a right or an oblique cylinder. Sometimes the thermos is easier to carry on a bike or a kayak if it is oblique. Inside each thermos is a small filter in the shape of a hexagon, which uses a thin hexagonal shaped filter paper. Extreme Exteriors always keeps a container of filter papers on hand. So the filter paper is shown to the side here, and the base of the container is congruent to each paper filter. So it says name the container. Well, it tells us right above that the base is the shape of a hexagon, 1, 2, 3, 4, 5, 6 sided figure. And if we're looking at this, we know that we can see that the bases are parallel to each other. They are congruent to each other, and the sides are made up of rectangles. Okay. Now again, the only two options you really have are a prism or a pyramid. Okay, and since this does not come to a point at the top and the sides are all rectangles, we are going to go with a prism. So this would be a hexagonal prism. Missing a few letters. Hexagonal prism. The area of each paper filter is B. Write a formula that finds the volume of the filter paper. So again, the filter paper is just this hexagon at the bottom. Okay. Let's find the volume of paper. So going back kind of to pre-algebra, so 6th grade, we learned that there's one volume formula for all prisms, and that is volume is equal to base area times height. And again, capital B is the base area. It doesn't matter what the shape is, we have the area of the base. So it says, suppose the radius of the container is 2 inches and the height is 4. So I'm going to add that over here. So height is 4. And it says the radius. Well, this isn't a circle, but I know that the circle goes around this container. So the radius is going to be 2 inches here. Asking to find what the volume of papers that fit into the container. All right, so a couple things I need to do. I have H. H is no problem. But I need base area. Well, how do you find the area of a hexagon? Well, the only thing I can think of to do would be to turn this into something that we do know, which are triangles. And we know how to find the area of a triangle. Now, since it's a hexagon, this would turn into 6 triangles that have a central angle of, well, 360 divided by 6 is going to be 60. Okay, well, I also now know that these are the same because they're both the radius. What else can I tell about this triangle? I know that the interior angle, and again, this was from a few lessons ago, I can find that the interior angle of a hexagon is 180 degrees, and if this is cut in half, we have, again, 60. So now it's telling me, guys, we have a equilateral triangle, and we have 6 of those. So we have 6 equilateral triangles that we have to try and find now. So now I'm trying to find 1/2 base times height. Well, the whole base of this, again, equilateral, is going to be 2. So little b, base of that triangle,